Appreciate it. Thanks, everybody. My name is Mike Angstadt, Director of Platform Engineering at HEB Digital, and welcome to DevOps Days Warsaw. Really excited to be here. I'm going to talk today to you a little bit about eliminating noise and urgency in your alerting and monitoring strategies. But if you're not from Texas or Mexico, you've probably actually never heard of HEB. So we're a $31 billion, 120,000 employee partner company with 360 locations. We've got over 1,200 workloads, 7,300 VMs, and two private data centers, as well as infrastructure footprint within each one of our stores, Wi-Fi networks, as well as public cloud at AWS, GCP, Azure, interconnectivity between all of those. And about $60 million a week in our online grocery unit. So you can imagine there's a lot of opportunity for things to go wrong. And so today we're talking about arguably the two worst things in alerting, noise and urgency. And so the working definitions we'll explore today, most people are probably familiar with noise, an alert that fires, maybe pages you. It doesn't indicate any actual real problem. And urgency, which is really the importance and how important it is to remediate that incident quickly. Your mean time to repair counts. This could be tied to business loss of revenue, dramatic customer impact. But as soon as you get that page, right, the clock is ticking. So today, I'd actually like to, if you'll allow, extend this definition beyond noise that alerts are just clearly firing and have no action. They page you, you wake up, things actually are fine, and maybe it's just some blip or oversensitive threshold, unclear runbook. But I actually want to extend that to anything that requires a unique human interaction to intuition to interpret. And we'll get into that. But if you've ever caught yourself looking at an alert and asking your team, hey, does anybody know if this is real? That's probably an alert that requires intuition to interpret. And if you're not a specific person, that can be with the domain knowledge to understand that. It's just as valueless as an alert that has no clear action. You don't know whether there's fire where there's smoke. And so just as worse as one of those alerts that's clearly a false positive, you probably end up having to wake up multiple other people or teams to understand whether the world's on fire, or if you can actually go back to bed and everything's perfectly fine. So to eliminate that noise, including our extended definition there, all of these should be treated like a production incident. Inspected at your next retro, or better yet, silence for the next teammate that's going to be holding the pager. And don't forget the cardinal rule of on call, which is leave it better for the next person, because that might just be you. So that sounds really neat. But how do we eliminate those noisy alerts? So for starters, turn off alerts that have no action. Trust me, it will be absolutely fine. Enable your team. So make it not just acceptable, but celebrated to delete these alerts. If they're not useful, they're not useful. If there's some real issue that alert was somehow covering up or attempting to cover, believe me, it will come back up in the form of an action item in the next incident post-mortem. And if an alert only needs sometimes an action, introspect on that as well and decide whether it's more of nuanced intuition that's required or domain knowledge, or it's simply changing the threshold until that alert actually always requires an action to take to remediate whatever is going on. And for those nuanced required intuition or special access alerts, identify and decompose them. And you can do this by being aware of how your incident management process works. So if you ever catch yourself saying things like, oh, we need to get Brent online. He's the one that knows what to do here. That is a huge smell. That is an indication that you need a magic human on your hands, and get rid of the magic. Next time you need to pull in a specific person because they're the only one that knows how to fix something, shadow them and write down exactly what they're doing. That make them think out loud. Maybe it's a specific system they only have access to that they can observe some telemetry that is indicative of what's going on. Or maybe some domain knowledge is just between their ears that they've never documented. But capturing this is really the first step towards eliminating them as a single point of failure, um, and is actually the start of your run book. And remember to write run books. This isn't for you at your best, well rested with the proper amount of coffee. This is for your worst engineering self, being woken up from a sound sleep without context or ramp. And it takes work to invest in that documentation and run book so that your responses can be unheroic and boring. That's really the goal here. And if you invest the time there, I promise you, your future self will thank you. You should really be striving to have it be the simplest thing ever to acknowledge, execute, and go back to bed, repair the system that has a real issue occurring, and make it so brain dead seem simple and easy that even your manager could do it. So that sounds great. But what about the real alerts? So we've eliminated some noise there, but where are we actually going with this? So at some scale, you're going to get a lot of real alerts. Everybody say it with me real quick. There will be another production outage, and it will require you to get paged and wake up in the middle of the night. I'm sorry, you can't avoid that. Even if everything that has happened already you've accounted for in a well-documented alert, the reality is that there always will be a brand new type of incident. And so reducing this noise only goes so far. And that's the hard thing about hard things, is that there's still work involved here to solve this. If all the computers worked without our help, none of us would actually have jobs. So we should be thankful for that. But assuming you've reduced the noise to a certain point, even though we can't eliminate all of these alerts, we can reduce the urgency of them. And really, the whole point of an alert and monitoring strategy is to let you know when something's categorically gone wrong and what you can do about it. And so if you have an alert going off, even if something is catastrophically wrong, if you can't do anything about it, go back to the reducing noise tips and work on that. But assuming we've got real alerts firing and we have real actions associated with them, let's talk about the urgency. So natural urgency. This is what I call a one-to-one mapping of an issue occurring, a page being sent out, and a required human interaction to restore service. The issue is more than likely causing some sort of customer or business impact. You're now under the gun to restore the service. If you're tracking any sort of accelerate metrics or mean time to innocence detection, repair, you're on the clock. And it's what every one of us dreads on call. That 3 a.m. page, that the world's on fire without a run book, your laptop's out of battery, and there's nothing you can do about it. You just rush into the fire, and try to figure out exactly what to do as quickly as possible. You don't engineer those type of on calls; you survive them, and it's unenjoyable to say the least. And so this really leads to what I call pager fear, right? Nobody wants to hold the hot potato going into a system that's set up this way for unsuccess. And there's no one really fun way to put this. If you're successful as a business and technology company, the number of real alerts you get will increase over time. This data set is from HEB in 2015 through last period. Over a dramatic, rapid acceleration of technology and online grocery growth for our company. And even with our best efforts and continued enhancements on how we handle production operations with excellence, this number continues to grow. You can see that trend line. It's not going down, it's going up. And this is inevitable. You add more lines of code, more customers, more systems, more complexity, it will trend upwards. So, not to be too doom and gloom here, but there's also a few ways that really don't help at all combat that. So these are the ways that don't work on how to improve your production operational sanity. So hidden hurt is the hurt that you shift away from being clearly measured and monitored. You move it away from your team, put it to another team. It doesn't actually make it go away. It just makes sure that it doesn't hurt your team's metrics or what you're measuring. So a few of these are, you could throw more people at it. You can hire more people to try and suffocate the rising number of alert volume, which will eventually cripple your ability to innovate, complete planned work, or be cost prohibitive at any interesting scale. Another flavor of that, you could outsource it entirely. Now, this is even worse because the actual issues that your team is creating that are plaguing your production systems might not even be seen by your team. So you're completely unaware and ignorant to the pain you're causing to your production systems. Huge step back. Or you could simply ignore them because computers are awful. And none of these are really effective ways to help here. But we're not here to talk about things that won't work. We're here for solutions. But there is hope. We have options here. Let's dig in and let's fix this. Let's see what's happening with some specific data. This is the last 90 days of real incidents from HEB. I mentioned earlier, there's about 16,000 alerts here. And each one of these had a required human interaction to remediate, believe it or not. There's ohms, physical host failures, disks filling up that needed resizing, batch jobs that failed and needed to be re-kicked off, some mainframe reoccurring issue I don't fully understand. And these are all things that product prices that might have been incorrect, all things that computers are really good at fixing if you have solid instrumentation and instructions, aka those run books for those computers to follow. And this is at this scale no less than 90 pages a day. So those require someone to acknowledge them, maybe do something. For us at HEB, it's definitely multiple people's full-time jobs, as well as several rolling interruptions in the form of escalations to pull in people that need to help assist, remediate, or identify an issue. And all of those are people from delivery teams that are actually being distracted now from their planned work and have no hopes of delivering on expectation for that work because they're being interrupted helping these issues. And I really don't care if you're the best technology company on the planet. You can't handle this many paged alerts without several people on call. And because these computers run 24/7, 365, you're definitely going to be woken up. So what can we do about this? I want to make today's problem tomorrow's problem. Middle of the night, let's take a look at it at 9 a.m. if it's interesting. So enter our best friend math, and specifically derivative calculus. So most of you are probably familiar with derivatives, the slope of the curve, right? What rate at which the function is changing, positive or negative. In physics, we would call this speed. And you say, yeah, get it, Mike, but what does this have to do with alerting? So if you've got a really solid alerting strategy with well-defined run books, maybe even some of the scripts you already need to be able to run to automatically mitigate it, you can set up those run books and functions to be run triggered by those alerts and documented automatically instead of sending a page to a human being to do the exact same thing. And you can start counting the number of times you're doing this auto healing. This gives you a data set now, a derivative data set that you can begin to operate on a higher level of data and set alerts on as well. The benefits of this are going to blow you away. So you've now taken the required human interaction a step away from the natural urgency by setting alerts on the first derivative data set. And maybe at your scale, a few dozen VMs restarting from out of memory issues is just normal, nothing to page about, and it's perfectly fine. But if those auto heals have crept up now and are a few hundred a day, you want to inspect and see what's going on. You might not even need to know right away. Maybe this is a Slack channel alert to a team channel that you can look at, or anyone can look at tomorrow, instead of having something that needs to wake you up today. And congratulations, if you've gotten to this step, you've actually taken a step away from the noisy pager and drastically improved your life and the lives of every engineer on your team while they're on call. And the reality is that a lot of modern systems already do this. It sounds hard or like this is new magic. It's really not. Newer implementations of infrastructure, maybe even at the application level. I mean, this is one of the major value props of things like Kubernetes, right? Or ephemeral workloads. The idea that you try it, and if it doesn't work, you retry it. Something fails, just do it again. You see this all the time at the application layer. Imagine if every request to an API, just if it failed, didn't do anything else, or paged a person to go investigate why a request didn't go through. That would be ridiculous. We do things like circuit breaking or exponential backoff and optimistic retry all the time in software. And we do these similar things now in infrastructure. But the important part here is for things that are built in, like VMware's distributed resource scheduler, auto scale groups, Kubernetes self-healing pods and containers. Don't just enable these things and take them for granted. That's how you end up in crash loops, killing underlying resources by spiraling automation, masking issues that ultimately lead to catastrophic failure. You don't want to sort of hide the hurt, right? You want to inspect these things. You want to count them. You've got the benefit of additional data here, and you can review it with your team and conduct regular activities inspecting this, just like you would do capacity planning for your applications or infrastructure. And so enough words, let's look at some more data in practice. So this is that same 90-day data set, but showing the slope of that data set. So the speed at which these alerts are occurring. And if this is automatically getting mitigated, this may only be interesting a little over once a week in a 90-day period. You'll also notice that this is oscillating around zero. So it's negative sometimes. If you had 100 alerts yesterday and 50 today, the slope is actually on the decline, um, which is potentially just as interesting to inspect, layering over your deployments, changes in infrastructure. Our data ends up being particularly jagged because we're a weekly business. And so Sundays are our biggest day of grocery sales. And so we have a regular cadence of just the normal business day for our hours of operation. And these jumping parts are the part that's interesting. It's not that an alert fired and that you automatically mitigated it, but what's the change here? And so if you look at this now and we layer over the yellow line as the initial natural urgency, and we've got the alerts first derivative data in blue, you can see that we've dramatically reduced the urgency here. If we set the threshold, let's say at 50, well, now we've gone from over 16,000 alerts that took human interaction to now we've only got 14 in 90 days that a human needs to go inspect and say, hey, why did this change dramatically? That's huge. That's being paged 14 times in 3 months instead of 16,000. And that might not even be data you need to page on. Maybe it's just something that you look at the next morning. And so now you're looking at the speed of these alerts versus just that natural first order urgency. And guess what? You don't have to stop there. We can continue this method to gain even more insight and move further away from that natural urgency and noisy pager. And so over time, you might realize that the first derivative alerting also has a clear mitigation. Perhaps that out of memory issue that you've automatically been restarting the VM, when it increases in rate, you do something like schedule on a different host or move to a different region in a public cloud environment. And so you can engineer against this data the same way you would that natural urgency to move your future on call self one more layer of indirection away from that noisy pager. Welcome to the second derivative, the slope of the slope, acceleration. So what's the rate of change of that speed? This is how it's easiest to think of really a physics problem. How fast the alert's firing in comparison to previous time periods. And you can set new alerts on this data set as well. Because remember, you're counting all of this, you're not just taking it for granted. And imagine we've gone from 10 automated restarts firing in the last hour to now 100, now 1,000 in 3 hours. I would say that that's pretty interesting and something that actually you definitely would want to page on. The idea here is that it should increasingly happen less often that you're in these kind of extreme circumstances. So it's more rare, but these inflections might be more meaningful than the natural urgency itself or the first derivative. And so when I describe going from 10 to 1,000 or 10 to 100 to 1,000 restarts in 3 hours, that might be something catastrophically wrong. You might have an entire rack that is failing or something awful going on with your data center, some deployment of code that's horrifically causing issues, or infrastructure data set. And so let's actually take a look at the data here. I think it'll make a lot more sense. And so looking at this, you go, well, Mike, that looks choppier and spikier than the first derivative data. And that's because it is. It's emphasizing significant changes in the slope of the slope in that natural urgency. Where does the speed increase or decrease the most? And so this acceleration of alerts is super interesting. And now you can look and see, because there's even a potential for negative slope, you may only be interested here when the acceleration peaks above 100, for example. That's indicative layered on top of your first order derivative and natural urgency alerting. as data sets to say something's pretty significant is happening right here. And so the great part about this, if you take a look and say, okay, great, let's set alert threshold for 100 acceleration. So if the rate of change has sped up to the point where we're exceeding 100, you've turned that natural urgency of almost 16,000 alerts in a 90-day period to 5 pages just by adding automatic remediation and being able to count this first and second derivative data. Imagine that, going from 16,000 pages to 5 in 90 days. It's pretty unbelievable. And so getting into some tips here, certainly don't try to boil the ocean. Eliminate as much noise as possible. That's why we started with that. You want to make sure that when you're taking a look at doing some of this urgency reduction, that you're operating on things that are real and things that you have a well-known mitigation for. The reality is probably most of the things that you do get paid for, have already happened, are your most common things. Pick your most boring and well-documented and frequently occurring alerts to start with. I used out of memory issues as an example. That's something that certainly plagues us from time to time on a regular basis. There's things like disks filling up. There's things like batch jobs that fail. If it's a simple fix and a 2 or 3 step process, those are things that you can codify with relative ease and trigger from that runbook. Don't forget to set your logs aside. But the reality is that a lot of those steps, as codified, will be a lot more consistent than having the rotating engineer on call actually take care of them. And don't forget to count this stuff. Don't just set it and forget it. That's how you mask issues, and you can cause a lot of pain in underlying systems and a lot of churn unintentionally if you're not looking at this stuff. Don't fear failure. This is a really important one, I think, just in engineering in general, but specifically here. You won't get this right the first time you try it. You're probably going to delete an alert that 1 out of 100 times indicates there's actually an action to take, and you're going to feel like a jerk afterwards. But retrospect on it, right? Learn from it. That's how you improve your systems, how you improve your strategy, and then repeat that. You'll get better at this. And it's important to remember too, this is an autopilot, it's a reducing method. And so none of this makes the alerts go away. That's not the point. They're a valuable part of observability. You want them to be meaningful. You want them to indicate that there's actually something going wrong with the system that's worth documenting and logging and being able to forensically inspect later on. But really, the point here is to minimize the urgency of required human interaction with your production systems so you can focus on the planned work to improve those systems and make on-call less of a pain. And that's the end of the talk. I'll return voice back to the MC. Thanks so much. Really appreciate y'all tuning in.